Hi everyone, welcome to Underway Learning Space. Today we'll be looking at semiconductors. We'll be looking at examples of semiconductors. I'll be looking at the properties of materials that make them semiconductors. So, first, a semiconductor is a material whose electrical conductivity is between that of a conductor and an insulator. It can conduct electricity under certain conditions. Common examples include silicon and germanium. So these semiconductor materials, originally at low temperatures, they behave like insulators. That is, they don't allow the free flow of electricity. But when there is an increase in temperature, when you increase their temperature, that is by heating, they behave as conductors. They allow electricity to flow through them. That is why in most texts and materials, it is regarded to as the material whose conduction is intermediate between an insulator and a pure conductor. So please note that on their own, at low temperature, they don't conduct electricity. But when there is an increase in temperature, or when they add impurity materials, that is, materials that are not pure semiconductor as they are, it enhances their conduction or conductivity. So secondly, properties of semiconductors. Number one, moderate electric conductivity. They conduct electricity moderately, that is not so high and not so low, depending on the temperature and if it is doped, right? So, but normally in their normal state, they conduct electricity averagely, but we can enhance this. That is what we'll be looking at in the subsequent slide. So the conductivity increases with temperature, like we earlier said. The conductivity can be controlled by adding impurities. Now, the process of adding these impurities is known as doping. It is used in electronic devices. Now, types of semiconductors. We have intrinsic and extrinsic semiconductors. Intrinsic semiconductors, they are pure semiconductors, no impurities added. Example, pure silicon. The conductivity depends on temperature here. Now, these are semiconductors at their purest form, that is when no impurity. By impurity here, we mean elements that are not semiconductors or materials that are not semiconductors, right? Be it metal or non-metal. So once there is nothing added to a semiconductor, the only thing it depends on to enhance its conductivity is temperature. So for intrinsic semiconductors, to enhance an intrinsic semiconductor's conductivity is to increase its temperature. An example is pure silicon, pure germanium, and the rest of them. But these are the two most common semiconductors that we talk about. We have the extrinsic semiconductors. These are impure semiconductors. Their doping is done to improve conductivity. They are of two types. We have the N type and the P type. So these impure semiconductors, we add other material in order to enhance their conduction, to enhance their conductivity. The process of adding these impure materials, that is materials that are not pure semiconductors, this process is known as doping. So let's look at the N-type semiconductor. The N-type semiconductor is formed by adding pentavalent impurities. When we say pentavalent impurities, we are talking about these impurities that have their outermost shell electron to be 5. Example, we have phosphorus. Phosphorus has an outermost shell electron to be 5. So you will note that semiconductors, they have their outermost shell electron to be 4. So when they undergo bonding, that is the semiconductor and this pentavalent impurity, they are going to have a bonding in such a way that they will pair electrons. So pentavalent impurities, they have 5 electrons at the outermost shell. So each of those four out of those 5 electrons will undergo a pair. They will pair up with the electrons, the 4 electrons at the outermost shell of these semiconductors, to bond, to form that bond. So you discover that one electron will be left from this pentavalent impurity. So that one electron that is left from this pentavalent impurity is what will now carry the charge round the material, that is after doping. So phosphorus is an example of this pentavalent impurity, and the majority charge carrier in pentavalent impurity or n-type semiconductor is the electron, which is the negative charge. So for p-type semiconductors, they are formed by adding trivalent impurities. Example, boron. It creates holes, that is positive charge carriers. Holes are the majority carrier. So for a p-type semiconductor, when you dope a pure semiconductor with a trivalent impurity, by trivalent impurity, we mean these impurities that have their outermost shell electron to be 3. Example, boron, as we have it here, and others. So when we dope this, boron has an outermost shell electron of 3, and semiconductors, both germanium and silicon, they have 4. So when this boron donates the 3 electron, they will form pair. So you have 3 pair. You realize that 1 electron from the outermost shell of that semiconductor will be left unpaired, which means boron will be left with a space to produce an electron to pair with that of the semiconductor material. So that space there is what we call hole, right? It creates a hole, and that hole is what we call positive charge. And the majority charge carrier in p-type semiconductor is the hole, or the positive charge, right? An overview: first of all, a semiconductor is a material whose conductivity is intermediate between a good conductor and an insulator. So we have two types of semiconductor. We have the intrinsic and the extrinsic. The intrinsic is a pure semiconductor that has not been doped, while an extrinsic material or an extrinsic semiconductor is a semiconductor that has been doped to enhance its conductivity. So under extrinsic semiconductors, we have two types. We have N-type and the P-type semiconductors. So see you in class next time. If you found this video helpful, please like, share, comment, and subscribe for more.
In our class next time, we'll be talking about
The PN junction, that is when we join this P-type semiconductor and N-type semiconductor, what does it form? We'll look at some electronic components and how they function, how the diode is used for rectification. So please don't miss the class for anything. Bye.